Alright, here we go. A little bit of factoring review. When factoring, we always want to look first for a GCF. So take care of that largest number that goes into all of the coefficients, and then the lowest exponent on every and all variables that are there. So after you've done your GCF, you then look to see how many terms. If we've got 2 terms, we learned about dots factoring, so that's our difference of 2 perfect squares. So like, for example, x to the 4th minus 25 over 81. So that's an example of our difference of 2 squares. So this would factor into x squared minus 5 over 9, then x squared plus 5 over 9. And then we would always look to see, can we factor it again? This one we cannot. So that one is going to be done. So that's our difference of squares. Also, if it's 2 terms, it could be what we're going to do down here, which is factoring of cubes, but we'll get to that one in a second. So then if it's 3 terms, that's going to be our trinomial factor. So that's essentially your guess and check. So you've got your combinations of things that are going to be positive when you factor, negative, all that stuff. And then 4 terms or more, then you're going to look to see if you can do your factor by grouping. It does need to be an even number of terms, though, in order to do your factor by grouping. So let's see if I have x cubed minus x squared plus x minus 1. So remember, our factor by grouping, what we would do is group the first 2, group the last 2, find your GCFs, which for these last ones, your GCFs would just be 1. So our answer ends up being x minus 1 times x squared plus 1. So that's our factor by grouping. Again, you could have more groups, so you could have like a couple more terms over there, so then you have 3 groups, and then you end up with a trinomial that you got to try to factor afterwards. But you still group things together, and the groups have to be the same size. So here's a group of 2, here's a group of 2. I can't have a group of 2 and then a group of 3. It doesn't work that way. So our new kind of factoring is our factoring perfect cubes. So for example, if I have this and it's cubed, that means it's x minus 4 times x minus 4 times x minus 4. If I multiply these 2 together, I end up getting x squared minus 8x plus 16. So then it ends up becoming this big, huge thing. X squared minus 4, remember when we factor that, that's our difference of 2 squares. That becomes x minus 2 times x plus 2. So just because it's written in this way, it doesn't always mean that you're just going to distribute your cube, which is what a lot of people want to do, and then they tell me it's x cubed minus 64. It does not work that way. It becomes this big, huge, long thing, and then you still even aren't done multiplying there, but hopefully you get my point. So difference of 2 cubes. So this is similar to your difference of 2 squares, but difference of 2 cubes. So if you have 2 terms that are subtracted and they are both perfect cubes, there is a very specific way to factor them. So the pattern is a minus b. So it's the cube root of this minus the cube root of that one. And then it's times a squared plus a times b plus b squared. The sum of the cubes is a very similar formula. So again, if you have 2 perfect cubes that are being added together, this one would be a plus b, a squared minus ab plus b squared. So the way it ends up being is this sign initially, that's always the same as whatever you had here. So that sign is always the same. The first set of parentheses signs are always the same. These next signs, those ones are always opposite. of whatever you had here. And these last ones are always plus. So that is the pattern it always follows. Same signs, opposite signs, always plus. And again, the same things happen when you take your cube roots of these, so it's always first, last, first squared, multiply the two of them, and then the last squared. So let's take a look at some examples here. So my first one, I have y cubed minus 8. So I'm going to rewrite my 8 as 2 cubed. So I have two perfect squares here that I am subtracting. So I need to follow my difference of 2 cubes formula. So that's going to be first minus my last. So my first would be the y, my last would be the 2, because again, 2 was my 8 cubed. So I've got to use the 2 and not the 8. So then inside here, it's going to end up being y squared plus 2y. You multiply those two together, plus y squared. So signs the same, opposite, always plus at the end there. That's always going to follow that pattern. So you got to figure out how to rewrite those things as whatever cubed, and then you can follow the formula a little easier. So like looking at example 2, this is really 1 cubed minus 3x cubed, because 3 cubed is your 27, so that's why I had my 3. X cubed would just be x, and then you would cube it. So that whole last term here would be my 3x cubed. So again, this one is subtraction, so I'm going to follow the same format. So it's going to be my first minus my last, and again, we're using the cube root of them essentially, my things that I rewrote them as over here. And then it'll be the first squared, so 1 squared is 1, plus the 2 of them multiplied, so 1 times 3x is 3x, plus the last one squared, so 3x squared would become 9x squared. And then that's your final answer. Now what always happens with these is, whatever the trinomial is here, that's never going to be factorable again, so we have to leave that the way it is. And I just realized that that should actually be a 4. So again, that trinomial at the end is never factorable again. You can't do anything else with it. So then that part is done. So if I look at my third example here, 3 is not a perfect cube. That doesn't help me with anything. So what I need to do is I need to GCF out a 3 still. Then if I do 192 divided by 3, I get 64. 64 is a perfect cube. So this is really x cubed plus 4 cubed. So just like all of our other GCFs, that 3 is going to stay out in front even when we follow the rules for our factoring of our cubes. It's not going to go anywhere. It's going to stay there just like every other GCF. So this time it's plus. So this is going to start out as x plus 4. That sign is always the same as your original problem. So then it's the first squared. This time it'll be minus because it's got to be the opposite of this sign here. Multiply the two of them together, and then always plus at the end, and then our 4 squared. So there's our final completely factored answer. So looking at our fourth example, 8x to the 9th is really 2x cubed, because 2 cubed is your 8. When I do my power to a power rule here, 3 times 3 is where my exponent of 9 comes from. And then my 125, that's going to end up being 5 cubed. So again, this one's plus. So this is going to start out as a plus also. That sign is always the same. So then again, in here, 2 cubed squared is going to be 4, x to the 6th, minus, multiply these two, 2x cubed times 5 is 10x cubed, and then plus 5 squared, which is 25. So there's our final answer for that one. Number 5, this first one's already written the way we want it to. It is a binomial, but it's a binomial cube, so that makes it a perfect cube. 8 can be rewritten as 2 cubed. So it's going to follow the same pattern. First, plus this last, because this one was plus initially, so this is going to be plus here. And then it's going to be y plus 1 squared minus 2 times y plus 1 plus 2 squared, which is 4. Now you will want to clean this up a little bit. This becomes y plus 3 because you add your 1 and your 2. This one you don't have to multiply that out. You can though. You can distribute your 2 here, plus your 4, and then still combining like terms. If you wanted to multiply this out, that would become y squared plus 2y plus 1, so you would end up with y squared. Your 2y's cancel each other. 1 minus 2 is negative 1 plus 4 makes that a 3. So there's a lot of manipulations you could do. Again, this term could be left as that. So y plus 3 and y plus 1 squared minus 2y plus 2. That could also work. If it's a multiple choice answer, you'll more than likely see that choice there though. So y plus 3 times the y squared plus 3. And then our last one here, this is xy squared cubed minus 4 cubed. So this is a difference of cubes. So that's going to start out as a subtraction. Squaring this would become x squared y to the 4th. And that would be plus 4xy squared. And then plus my 4 squared, which is 16. So they all follow the same pattern. You just got to remember it. You got to figure out what is the perfect cube, so the cube roots essentially, and then follow the pattern. The first sign is always the same as what you start with, and then it's the opposite sign, and then it's always plus at the end.